This video was brought to you by Indently.io, learning Python made simple.
How's it going, everyone? In today's video, we're going to be talking about 5 tips for writing more professional code in Python. Starting with tip number 1, following PEP, which is Python's enhancement proposal. It's not required, but it makes writing code consistently much easier. For example, we could write code like this. We can type in my score of type integer equals 0. Then we can add a semicolon, and immediately after we can print my score. This is perfect. It's allowed. You can do this. The syntax works, and it even saves us one line of code. But if you ever hover over this, you'll notice that we're breaking a few of the rules. One being that we missed a space after the semicolon, and the second one being that we have multiple statements on one line. And the reason it recommends we don't do this is because it quickly becomes illegible. And we can even add another. We can type in x of type list of string and say that's equal to A and B. And at this point, it can be even quite hard to understand what we're doing. I mean, it is quite hard to understand what we're doing because we have 3 statements on one line. And this just isn't that common of a thing in Python. And PEP is going to recommend against it. Another example would be if you were to print, let's say, hello, but you were to add a bunch of spaces around everything you're doing. You'll notice that if you hover over that, you're going to get another PEP warning. So we just broke another PEP rule, that we have a space after the parentheses. Now, if we were to run this code, it will run perfectly fine. Nothing is wrong here with the code per se, but if your fellow developers ever see this, they might have some trouble reading it. So PEP is just like an international rule set that we should all follow just to make it easier on each other, so that when we read the code from GitHub or from anywhere else, we'll know exactly what we're looking for. Now, if I were to use the auto formatter, it's going to end up looking like this, and we can even remove those semicolons. And I know it takes an extra 2 lines of code, but readability should always come first. Which actually brings me to tip number 2. Prioritizing readability. Now, I love sharing a lot of crazy tricks on this channel, but unless you hate your colleagues or are trying to show off to your AI-generated girlfriend, keep your code legible so that you can change it easily in the future. Also, so that your colleagues can change it easily in the future. For example, imagine you want to create a function where you calculate the factorial of any number. Now, we could do it on one line, like this, but look how complicated this is. First, we're using a one-liner to return a couple of lambdas, and this will calculate the factorial. I mean, right here we can type in f, or actually we need to print this, so print f of 10, and we'll get the factorial back down here. But if we ever have to change this in the future, it's going to be nearly impossible unless you add some comments or unless you're really paying close attention to this code constantly. Now, if I ever saw this, I would give up and change to an easier language such as C. So what I would prefer to see is something like this. I know it takes a lot more lines, once again, but this is actually legible. And we have some more information here, such as raising a value error if the number is negative. We have the appropriate logic here, which of course you could add inside here. But once again, what matters is that you keep it simple and readable, because this is something we can change while this is something we cannot change. Or we can change it, but it's just going to take a lot more time and effort than trying to change anything inside here. And they both do the same thing, and I can prove it by typing in print factorial of 10 and print f of 10, which will give us the result of the factorial of 10. Moving on to tip number 3. When programming in Python or any other programming language, I always recommend you use a linter and a static type checker. And on this channel, the static type checker that I use is MyPy. Now, that might change in the near future. What matters is that you choose a reliable static type checker. Now, what linters do is make it easier to follow the rules, and they also make it easier to spot errors. Static type checkers just help spot the incorrect types before you run your script. Now, both contribute to your code running more successfully and with less errors, unless you are a rebel and ignore them because you believe in the freedom of not being told what to do by anybody. So right now I have MyPy installed, which means if I were to create something called my number and say this will be of type integer and assign it the value of 10, it will run perfectly fine. Then I can print my number, and as you can see, we have no errors. There is nothing wrong with this code because everything adheres to the rules. Now, at any point, if I were to change my number to a string, such as Bob, I'm going to get this syntax highlighting by MyPy that I have an incompatible type because I inserted a string here when it expected an integer. And this warning can save us a lot of trouble in the future before we run the code. Or another example, pretend we have my number here, but it's very late at night and I accidentally pass in the string of 10. Now, obviously, I'm dumbing this down a lot. This isn't a mistake you make all the time, but you just need to make this mistake once to actually encounter an exception. And once again, thanks to MyPy, even if I'm drunk, I will not make this error because I have the static type checker to save my butt. Which means if I were to do my number plus 1, I will notice I made an error here and I'll change it back to 10. Without the static type checker or the linter, I'm probably just going to run this and encounter the type error and then change it later. But that did require me to go back and actually fix the problem. Now, simply put, you might be asking what's the difference between the linter and the static type checker? Well, the linter pretty much is just something that helps you follow the rules. So for example here, if I were to add a lot of spaces, once again, you'll notice that we're going to get that syntax highlighting that we're not following the rules of PEP. And that's the job of the linter, while the static type checker, once again, just tells you whether you are using the correct type or not. So if I were to pass in Bob, once again, you'll notice that we're going to get some syntax highlighting from the static type checker. Up next, we have tip number 4, taking advantage of built-in modules and functions. Now, writing functionality from scratch can be a fun way to learn a language and show off your knowledge, but I wouldn't recommend always doing that. Python has a lot of built-in functionality, and chances are that there is a function already built for what you're trying to do. Now, the reason I recommend using the built-ins is because they are created by professionals and are highly optimized. This just means that coding your own version of any built-in function will probably lead to more work and poorer results. For example, imagine you have some numbers, which are a list of type integer, and here we're just going to type in 1, 2, 3, and 4. And what we want to do is get the maximum, so we'll type in maximum of type integer and type in max, and then pass in the numbers. Now, if we were to run this, what we should get back is 4, and everything went smoothly here. We did exactly what we wanted to do. I mean, obviously we don't need to create a whole new variable for that. We could also just pass it in directly. That's not the point. The point is that we used the built-in function of max. Now, let me show you the alternative and what some people end up doing because they think they're much smarter than the Python devs. So let's get rid of this, and what I'm going to do is paste in this function called custom max. Now, as you can see, we're doing our best here to recreate that functionality. And what it does is take a list of type float as an input. And if the list is empty or none, we raise a value error. Otherwise, we try to get the max value. And I mean, we do the regular logic for that. Now, I'm actually going to grab the numbers and paste it right under so we can try using it. So what I'm going to do is print maximum, once again, of type integer, and that's going to equal the custom max value. Then we can pass in the numbers. And MyPy is not really happy with this because we typed in list of float and that we will return a float, while here we have an integer and we inserted a list of integer. We're just going to ignore that for now because we know that's going to work even if it's not a list of float. But next, let's print the maximum. And when we run this, what we should get back is 4. Because that's the max of this list. It still works. So we might have managed to build a custom max function, but it cost us a lot of time and effort. And we still have a few bugs to work out, such as what type this should accept and what type this should return. And not only that, the only thing we covered was the value error. We don't even know what other exceptions this could raise, while the built-in max function already covers everything. That's why you should always use the built-in functions before trying to recreate your own, unless you absolutely need your own custom logic. Because I mean, first of all, we wasted 9 lines of code for this, and right here we can just pass in max, and we don't even get any errors from our static type checker because max already handles the generic types. If we were to hover over that, you'll notice that it has some interesting documentation with some generic types. Also, I didn't even recreate the key functionality in our custom function. And another good reason to use the built-in functions is that most of them, if not all of them, are written in C. And that's just something we cannot compete with when we're coding in vanilla Python. And finally, the final tip of the day is to read the docs and explore other random projects on GitHub. It's very important you do this. Do not get comfortable with only writing your own code. Make sure to explore the docs and practice reading other people's code 2. There are a lot of crazy programmers out there, including myself, and we all have different styles of coding. Some will inspire you to improve your code, and others will inspire you to quit your job and go live on a farm with your pet sheep for the rest of your days. But all jokes aside, keep exploring and reading. Even after all my years of writing code in Python, I discover something new almost every other day just by reading the documentation. For example, if I were to write some code, it would probably end up looking like this. I would first create a variable at the top, I would give it its appropriate type, and then I would perform some sort of action on that list, such as appending an outer and an inner number in the form of a tuple. Now, the logic behind this doesn't matter, and when I run this, what you're going to get back is 00, 01, 02, 10, 11, 12, and so on. This is just my coding style. What it actually does doesn't matter in this example. But maybe someday I'm reading the documentation or I'm scrolling code on GitHub and I encounter something like this. This could be someone else's code. I mean, they don't annotate it because a lot of the code you'll find on GitHub is not annotated. Type annotations are still relatively new to Python, but still this might inspire me to find a better approach to what I'm doing, such as using a one-liner and a list comprehension as opposed to a for loop. And learning how to read this makes you a good programmer. And again, even if this doesn't use type annotations or might even be a tad illegible, it still can inspire me to think outside the box and remind me that in some places I could improve my code with list comprehensions. It just gives me more ideas and also improves my ability to read code. That's why it's very important you explore documentation and other projects on GitHub. It gives you better ideas and will help you innovate. Do not get stuck in the bubble of writing your own code 100% of the time, because it's very easy to get comfortable and stop improving. Anyway, that's actually all I wanted to cover in today's video. Do let me know in the comment section down below whether you have any tips for coding more professionally in Python. But otherwise, with all that being said, as always, thanks for watching and I'll see you in the next video.